Okay, the law of conservation of energy is the second conservation law that we're encountering here in our physics course. And I used to illustrate the law of conservation of energy by using a bowling ball. I used to have a bowling ball in my classroom. And I'm going to try to draw a reasonable facsimile of a bowling ball. So there's a bowling ball. It was hanging in my classroom. We could first of all say, oh gosh, what when it's hanging down straight, what kind of energy does the bowling ball have? It really has no energy. If we call this, its lowest height, then it's got no energy of position, it's got no energy of motion, it's got nothing. And so you do have to do a certain amount of work in order to pull the bowling ball back. But you can pull it back to, say, this starting distance or this starting height. And the interesting thing about the bowling ball then is that when you let it go, it's going to swing down past its lowest point, continue on, and wind up at the same height that it started on the other side. And then it's going to stop, and it's going to turn around, and it's going to go back through the low point and wind up where it started, back and forth, back and forth, back and forth. It's never going to get higher than the height from which it started. That would be a violation of the law of conservation of energy. Conservation of energy says, once I've given this thing some energy, and once I pull that bowling ball back and I let it go, and then as long as nothing else touches it, it's going to continue to swing back and forth, never reaching a height any higher than where I released it. So that's why I used to be able to stand here with my big old schnoz, my big old nose here, and I could feel confident that that ball would never swing back and hit me in the nose. As long as I released it from a point lower than my nose to begin with, it would never swing higher, unless some student who had had enough of me came along and gave the ball a shove. Now that would be an outside force acting on the system, essentially adding energy to the system, in which case, yes, then the ball would swing back and clunk me in the head. But as long as there is no outside force, there's no outside force doing outside work on the system, then the law of conservation of energy will be upheld in this situation.